Hello friends, welcome back to the channel. We've been working on our little compiler that is backed by LLVM, and when we left off last time, we had it doing variables, which was quite exciting. You can set a variable to a number or a string, and then you can get it back out again. Quite fantastic little stuff. So if I run that, it's going to generate the IR and feed it into LLVM, and it's going to compile and run, and we get the result we would expect. So yeah, I had a lot of fun doing that. Check out the previous videos if you want to see how we did that. In this one, I thought we would do something a little different, like maybe puts x plus 4. And what I would expect out of that is 7. I would expect it to do an addition operation if the types of the operands are numbers, and if they are strings, then it should do concatenation. Yeah, something like hi plus friends, something like that. And we're going to teach the compiler how to do that. I don't really know how to do that yet. As always, I'm living on the edge of my knowledge, and this is not a how-to. This is just Tim learning it on his own as he goes, and you get to follow along if you're into that sort of thing. So definitely hang out if you want to see if it works. So yeah, we need to figure out how to make this work. I don't know how to compile function calls yet. That is a message that I added when we added the puts function call, which isn't really a function call. It's kind of a fakey thing. And I guess we're going to fake this one too. It's not going to be a user-defined function. It's going to be a special branch of our compilation. So it's going to live right here, I think, in this, when we're walking the tree of nodes, the syntax tree, and we get to a call, then we want to handle certain calls differently. And let's do this. Let's say I got, and let's print out what we got, which call node looks something like this. Message. Yep. So let's run that. Rake LVM and run that. Okay. So it definitely got the plus message. So I guess we'll just handle it right here. I'm just going to work on the simplest possible thing that can work. If gotta copy this actually, and then I don't need this part, I guess. I just want to compare the message to plus, and if it matches, then we're going to do something. And we need to branch based on the type of the arguments. Let's say if call node args. Well, actually, let's just do an assertion. Let's cheat. So let's say 2. We're going to assume that there are 2 arguments, and we'll do auto left equals call node args 0, and right is 1. And we're going to say if left, and these are nodes. Yes. Like, let me just make sure. I believe they're nodes. So this says cannot initialize a variable type character with a node pointer. Yeah. So we actually want to walk the tree to produce the LLVM for these 2 items. Builder. Maybe, did I do this wrong? Walk tree with a node. I thought that's how you did it. Walk tree with a node. Oh, I have to pass in the variables. We added that in the last video, so I need variables. And we'll do the same thing here. Walk tree, builder and variables. And so now I can say if left get type, I think I want the get type. It might be get allocated type, but no, I think that's only for the alloc A that we did in the last video. So okay, I'm pretty sure it's get type. Get type is string type, and write get type is string type. Then we're going to do something. Else if left, yeah, let's copy that. Let's be lazy here. Else if it's an I, how did I do that before? I did the integer, I just have it right here. I64. Let's move this up to the top so I can reuse it. Might need to make it a global. I64. So let's say if this is an I64 and then this is an I64, then do something else. Else, we're gonna print something out here. I don't know how to compile operands of type, and I think I can do, this is kind of mixing and matching styles a little bit. I probably shouldn't be using printf. Actually, maybe I should do C. No, I'm just going to do this. Printf and then left get type print LLVM out. And I think that will print the type information. There's probably a better way to do this. Maybe there's a way to print it to a string. Was there a different print? Is for debug false. It's okay. We're just going to go with this. We can always improve it later. I probably want to raise an exception instead of just doing printf and abort. But that's okay. That's okay. So let's just see if this even works. Got two strings and got two ints. And then what we need to return something. What are we going to return? I'll just return a 1 or something. 1. Okay. Does that compile? It should say got two strings and then print a 1. No, didn't do that. Assertion failed, 2 args. Oh, it doesn't have 2 args. That's right, because if you do 2 plus 2, then what you get is the receiver is a 2, and then there's only 1 arg. That's right. Okay, so 1, and then left is going to be call node receiver, and right is going to be args 0. Okay, so let's try that. Nope. Okay, and it said got 2 strings, and so if I do this with 3 puts x plus 4, then it should say got 2 ints. Okay, that logic is working. Now we need to compile the actual operation. For strings, I need a new function because that is in C++. Let's see, Natalie, string header. I think I need a new, should it be void? it needs to be, we don't want it to mutate the string. So this would be creating a new string, nat string concat const Natalie string left, const Natalie string right, and then we'll go over to string CPP and implement that. We have to do it extern C. That's in one of our videos. I have to do it extern C so that LLVM can call it like a C function. And then this goes here. What is this? Oh yeah, it doesn't return anything yet. That's okay. So I believe I can do auto let's just say copy is new Natalie string left, and this might need to be dereferenced. I need to look at, I don't remember how I did the copy constructor. Looks like either one works, so that's fine. We'll do it with the reference, and then copy append right, and then return the copy. So that's how we can do a non-mutating concatenation function. And then we need one of these, nat string concat redefinition. Wait, what? Oh, okay, function. And just copy some code down here somewhere. We'll put this right here, and we'll paste the sort of declaration here, like so. This will be nat string concat. And then the function type is, it's going to return a string type, and it's going to take a string type and another string type. String GT. There we go. Okay. Nat string concat prototype, and then this is nat string concat function, nat string concat prototype, nat string concat. And so now we've defined a link to that function that we can use up here. We can say how do we do that? How do we do that? That's a call. It's going to be kind of like this string right here, isn't it? Where we create a call. I'm going to copy this so I don't have to retype it. Okay, so get rid of that. So we don't want the C stir. We don't care about that. We don't... actually, we don't need either of those. Concat function. We're calling this, if we're returning the result, we're going to pass in the left and the right. Oh, yes. If that just worked, that is so easy. I have a feeling, though, that I've missed something. If that says hi, friends, oh, it's compiling a lot of stuff. It worked. Oh, that's so cool. Let's look at this code. We get a new string. This is @0, which is the hi string. We create a Natalie string out of it. We allocate a space on the stack and store that pointer in a register. Then we store the string in it. Then we get it back out. And then we call nat string on a new string. This is the @1, which is the friends string. We concatenate them together We get it back to a C stir so we can pass it to printf, and we print it out, and it says hi friends. It says hi friends. Hi friends. That's so cool. This is fantastic. I love this. This is so much fun, and LLVM makes that really easy. I did not have to worry about assigning these temporary variables or registers. It's fantastic. So what do we need to do for the integers? I don't know exactly. I have pulled this up, create add, which is off of the IR builder, and it looks like you just pass it left hand, right hand, and an optional name. I don't know what has NUW and SW. I'm just going to assume that those can stay false. So left hand, right hand, and then an optional name. So wait, what was it called? Create add. Okay, I mean, it might really just be as simple as return builder.create add left, right. I don't really have a name for it. Oh, let's call it add. Why not? Okay, I did misspell that, builder. Okay, so does it work? 3 plus 4 is 7. Oh, that's so cool. What? Okay, so what's going on here? Here's our 3 being stored in our stack allocated space. And here is a 4 being put into a register. No. This is us getting it back out of our stack allocated space. Here's the 4 being passed in directly to the call to add. Oh, this is really simple. It's just add. And then we get the result of add and we pass it into printf. And that's that. So what else can we do? So if I say x is 3 and y is 4 and z is high and I'm running out of letters, a is friends, can I do puts y plus x and puts z plus a? Yeah, it works, except I missed a space. Ooh, what have I done here? What did I do here? That looks kind of weird, doesn't it? It's like there was some missing null termination there. I think, though, let's see. What's happening here? What are we doing here? If I give it another string, it uses the length. It does not append a null terminator on the end. Okay, I think it's right here is what I messed up. Total length. Well, that I think that fixed the issue with that. I wonder how long this has been a bug with Natalie, and why we haven't figured that out. Okay, well, I think that was the problem. Okay, so fix string concat so it always gets a null terminator. Yes, that should fix that. And then let's go through this. No, yes, 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 and yes. Okay, add plus operator to our little toy compiler. Fun! Well, here you go. Puts 3 plus 4. That works. On 400. If you use a variable, it it's not defined. It says variable not defined. Let's do x equals 3, puts x plus 1. Does it work with negatives? It does, because our parser handles that. What else can we do? Plus, do the same variable twice? Interesting opportunities for optimization right here. So loading the same thing twice. Oh, but this is so much fun. This is so much fun. So I would probably leave as an exercise to the watcher some ways to clean up this code. It's obviously not ideal. My goal here was not the most elegant way to do this. It's just how to make it work. This switch statement is getting kind of unwieldy, but I think moving this logic into objects is something that I could do. I don't know that I'll make a video about it because that doesn't seem very interesting. Unless you think I should, let me know in the comments. But yeah, I think if we had an add class, we could call into that and move a lot of this logic out, or we could have it implemented on our types. So like we have this string type right here. We could probably implement something along those lines or whatever. We have lots of options, but this turned out to be pretty simple and a lot of fun, and it's starting to make our little compiler actually, I mean, it's becoming a little calculator. It can only do addition right now, but it wouldn't be hard to do a minus. And so what would minus do for strings? Well, what does it do in Ruby? Hi minus friends. So you can't do that. So we would need that to be a compile error. So it'd be a case of duplicating this code and then say if it's a minus, then do this. If they're ints, then do sub, create sub, I believe. And if they're strings, then we would, say error like so, and abort. So not too, well, I gotta play with it. Why not? Well, that worked. Should I commit that? I mean, why not? Why not? Error cannot subtract strings. Abort, and let's commit it. I mean, we're here. We might as well add subtract operator. Oh, I didn't do that the same. Let's do minus operator. Oh, this is just so much fun. I enjoy this stuff. Figuring out how LLVM works and how it just does so much for us that I would have had to do myself. This is really cool. Now I can see why people are sold on LLVM and why there are so many compiler projects built on top of it. So I don't know, I'm going to keep going. I don't know what we'll do next. Maybe user-defined functions. That could be cool, because then we could create a function called add, ADD, and it could do the plus for us. I mean, it's not super amazing, but it could at least prove that we can build functions and take arguments and do a return value from the function. So yeah, I might do that next. If you liked the video, please like and subscribe, all the usual. But definitely check back for future videos. I just love doing this stuff, and I like sharing it with you all. I hope that you have some side project you're working on and getting some enjoyment out of programming. I think programming is a ton of fun. And yeah, I mean, what else can I say? It's a ton of fun. I hope that you find it as fun as I do, or maybe more. But that's it for this video. I hope to see you next time. Bye.